Hi, yes, we're continuing now. Let's welcome Runxin Li, staff engineer at Foursquare, as he unveils the intricate workings of their movement engine in his talk, capturing and validating real-world movements of millions of people. At this year's conference, Foursquare is a bronze partner, and we would like to thank you for supporting us. Runxin, please welcome to the stage.
Thank you. Hello, everybody. My name is Runxin. I'm a staff engineer at Foursquare. So today, I'm going to talk about how Foursquare utilizes our owned and operated apps to help us validate and come up with real, meaningful data that to detect people's real movement in the world. And all of these components will power Foursquare to be the leading location intelligence company in the world. We help people, reconstructing their daily diaries about where they move from place to place. We are generating data that help people, from billions of GPS records ingested daily across the whole world. This is the outline of this presentation. I'm going to talk about the who, the what, and the whys of what we do at Foursquare. First, I'm going to introduce Foursquare to people who are not familiar with what we do. And then I'm going to talk about why are we doing things our way. Then I'm going to use some examples to show what our methodologies are. So first, what is Foursquare? What do we do? Here's a very pretty animation showing a device moving from places to places. In summary, Foursquare translates raw signals into meaningful data about places and the movement between them. So some of these raw signals include raw GPS pins that every mobile phone has nowadays. Some of these data includes, information about a venue or a place on the internet. What we do is that we construct more abstract levels of representations of these data so that they can be used in real use cases. Let me talk about the three pillars of Foursquare. Foursquare started in 2009 as a consumer app company. Right now, of course, we, over the years, we made a few transitions and we evolved. But we still have two major consumer apps called Swarm and Foursquare City Guide. Swarm is the so-called checking app, where you can use the app to record where you have visited. If you want to do something like recording your daily logs or recording your travel logs, that's where it comes in. Foursquare City Guide is kind of a location discovery and recommendation system. For example, when I arrive at Belgrade, I ask myself, what restaurant should I go if I want to taste some local cuisine? And Foursquare City Guide will return you a list of recommendations based on the location and the personal preference. Over the years, we have actually transitioned ourselves into more of a data and technology company. Two of the most important data sets that we own are the places and the movement. So places are just, POI information from both user-generated data from our own apps and also web scrape data from the internet. I'm going to talk more about the movement data today because that's what I work on in the company. What is a movement? Movement is basically, talks about user stops. We have algorithms for doing stop detection and snapping these stops to places. In the future, I think where this company wants to become is a platform company. We want to become the best location platform in the world so that we can serve many different customers, such as advertising marketers when they want to run measurement and targeting business. We want to serve the enterprise clients who want to run business intelligence and insights and analytics. And also, there's a major part in our offering, which is the Foursquare Studio. It's a visualization and analytical tool. And we will have some huge launch of a new product next year based on that. Although I've talked about what we do in the location business, but let me just bluntly say that location is hard. Doing location right is hard. The main reason for that is the input data, which I just talked about, the raw GPS pins, they have a lot of errors. For example, especially if you're in a very dense urban area where there are a lot of high buildings blocking the GPS signals from the phones to the satellites, the errors can be as far as 100 meters away from your location. It's like you're actually inside shop A, but your device, your latitude and longitude from the GPS tells us that you are actually 100 meters away from that shop, right? Compared to some other well-established fields in machine learning, such as image recognition and natural language processing, this is especially hard because for example, in image processing, when you see images, they're basically a bunch of pixels with RGB values, right? There is very little noise in those values. I mean, sure, there is resolution issue, or some pictures are blurred, but when you see the RGB values, they are always correct. And in natural language processing, it's the same. When you look at the text, sometimes there are typos, but when you see a letter A, it's letter A. It can be letter B or C. In location, it's not always the case. So some more concrete examples of the challenges we face in this industry. First of all, data acquisition. As much as we want to make this world to evolve around Foursquare, that is not the reality. So what that means is that we have to supplement the data we collect ourselves, what we call 1P data, by purchasing these third-party data from other providers. And I can tell you the data quality is not on the same level as our own data. And also, there is increased concerns and awareness of privacy across the world, both from the operating system from, for example, Google and Apple, and also from the users themselves. I think in general that is a good thing for the society. People should be careful when it comes to privacy. I think a lot of the companies in our field consider this more as a negative thing or a meh situation because it makes it harder to collect data. But actually for Foursquare, we think of this as an opportunity because when you have the right technology and algorithm, you can actually do things based on the noisy data that other people cannot do, while respecting the privacy of the users. So it's a win-win situation. A third challenge we have is how to acquire the so-called ground truth data, because a lot of business, they have their own transaction and sales data, right? That's what we consider the best data, the closest data to what happened. But it's also very hard to buy these data from the vendors. And even if you have some data from the vendors, those data are largely biased. You know, different businesses, they're probably curated towards different demographics. You know, a shop that sells, for example, you know, men's sporting clothes is going to have very different user base than a place that sells, you know, women's shoes, fashion shoes. So that's where the normalization and evaluation comes in. And talking about evaluation, it is still very hard because In this industry, there's no such thing as a well-established open source data set where everybody can just use to run model evaluation and assessment. So we have to come up with the evaluation data set ourselves. So what makes Foursquare different? What is the differentiator of Foursquare to other companies in location industry? That's where our owned and operated apps come. So here I listed some of the main features or advantages of our own apps. I'm not going to bore you guys with all this marketing material, but I just want to emphasize that first of all, we only collect data from consented users, where the user gives us permission explicitly to share the location data with us. And we also have a global coverage, which means we don't just run our apps in the US. On the right side, you will see a screenshot of our Swarm app, where you can see that basically for this user, this user checked into those two places today with their timestamp and venue name. So over the time, this user will be able to build a kind of like a location live logging journal for her, so that we know what is her favorite places to go to, what is her visitation pattern. So how do we do things in data science, in our data workflow? So here is a very simplified version of our data flow for generating visits. We always start by GPS pins, mostly coming from the third-party providers. We need to use our 1P data to run evaluation and assessment for these third-party providers, because as I mentioned, the data quality is just not that good. And then we convert these raw GPS signals into raw user visits by using our proprietary algorithms to attach places to stops when we detect a stop. And that also depends on our historical check-in data, our 1P data. Then a lot of the business actually, they don't want the raw visits, raw individual visits from users. They want the aggregated visits normalized to match the different demographic distribution of different areas. So we need to generate the normalized user visits as well, and then I will later show you an example of how we use our 1P data to do that. So first of all, let me talk about the provider evaluation. Basically, we ask ourselves this question: how far away, when the device coming from the 3P provider generates a stop, we ask ourselves, how far is it away from what our apps tells us about the same device? So we come up with some very simple measures, simple criteria, like if the distance is within 250 meters, we consider that as a good stop from 3P. And it's a bad stop if it's too far away from the 1P signal. On the right side, you can see a bar chart representing different providers whose name I shall hide here because I don't want to start shaming the providers. But you can clearly see that there's a huge difference between this red provider and this green provider. So the bar chart, the gray part represents the percentage or the portion of good stops from this provider. The higher the gray bar is, the better, right, for this provider. And the dotted line represents the raw volume of this provider. So between the red and the green provider, you can see they give us more or less the same volume of data. But one provider sends us about 80% of the data as good stops, while the red one is almost all fake or bad data. So when the next time we ask ourselves which provider we want to kick out of our supply chain, we know which one it should be. Furthermore, we can actually use this data to train a simple veracity model to, to tell us, to give us indications on, what the confidence is we should give to each movement data, such as stops or visits. And oftentimes, we want to introduce new providers. And before we start, paying them money to buy their data, we want to do some initial evaluation as well. The evaluation is usually based on these different dimensions or criteria. But so basically, on the right side, it's a simple representation or visualization of a side-by-side comparison of this new provider versus our first-party data. So you can see that on the right side, our first-party data, this is a map of Manhattan, New York, by the way. You can see that the visitation has much larger density or volume around Midtown New York, Midtown Manhattan, which makes sense. On the left side, you see this new provider heat map. So in pure volume perspective, it cannot compete. It cannot compete with the volume of our first-party apps. But if you look closely, the distribution is actually very similar, which means that this provider is not trying to, fill us with fake data or artificial data. So that's a good thing, actually. So once we have figured out, what are the good input data, we run our algorithms to generate visits. So what is a visit? Let's try to define a visit. So in a mathematical form, a visit is basically the venue that has the highest probability given a stop, right? So on the left side, we generate stops using our movement algorithm. So we generate 9 billion stops per month from 500 million unique devices globally. On the right side, we have our own places database, which is a machine learning model that contains all the different information such as address, category, that kind of information for different venues in the world, or chains. We use different resources, different sources of data, such as web scrapers or user input data. And we combine those to generate the visits by using our snap-to-place algorithm. I'm not going to go into details, but basically the features that are used in this algorithm can be categorized into 3 major categories. There's the proximity feature, which is basically how far away is your phone from the latitude and longitude of this venue. The closer it is, the higher probability it has to snap your stop to that venue. And then there's the popularities feature, which is kind of like a prior probability feature, which tells the historical popularity of different venues, because some venues are just more popular than the others, right? And then there's the personalized feature based on your personal preference and what places do you usually check into. We combine all these different features in our snap-to-place algorithm to generate visits. Here is actually more concrete example of how this works. So in summary, you can basically consider visits as mini-me's or clones or copies of our check-ins. In this example, you see, so the pin represents the location of the stop. And then we look at the stop, and we notice that there are 3 major shops nearby. Chipotle, which is a fast food chain, Gap, and Whole Foods, which is a grocery store. And we look at all the historical check-ins in our 1P database to those different places. We notice that 6 out of the 10 nearest check-ins belong to Chipotle. 2 of them belong to Gap, and 2 of them belong to Whole Foods. So we know that we should assign higher probability of the stop to Chipotle than the other venues, right? So this is only a very simplification of our algorithm. In a more mathematical form, you can think of this as a non-parametric model that tries to learn the shapes of different venues, not from polygons or satellite maps or OSMs, all that stuff, but from our user check-ins. The reason for that is, over the years, we realized that, the actual shapes of venues, a lot of time they expand beyond the physical shapes of themselves. So when you use a polygon or a hand-drawn shape, they actually don't represent the how people visit these places in real life. So when you use check-in, so on this page, I'm showing a very colorful picture representing Central Park. So each different color represents different venue that has the highest number of check-ins in that pixel or in that area. You can see that there are some larger places and there are some smaller places. So the example I'm showing here is the green blob at the left bottom corner of this map. It represents the sheep meadow, which is basically like a lawn, like a large lawn in Central Park. You can see that it basically represents the shape of the meadow itself pretty well. Here's another example, one of my favorite examples here, to show how powerful the check-ins are. You can see that at the middle of this map, there is a very small blue blob that, I'm not sure if I can point, right here. You can see this blue blob surrounded by this red blob. This blue blob is called Metropolitan Museum steps. The red one actually represents the Met, the museum itself. So why do we have some information about this seemingly random venue called Metropolitan Museum steps? That's because our users created this place as a separate venue. And I think it makes sense because it is kind of like a very, famous place to visit. If you're a Gossip Girl fan, you know what I'm talking about. But basically, this shows our high granularity and resolution to be able to construct the shapes of the venues from check-ins, from our first-party owned and operated apps. So once we generate the raw visits, we need to aggregate them into normalized visits to reflect the ground truth in the real world, right? So I'm going to show you an example of how we do that. So basically, over the years, we realized that there's a lot of fluctuation and volatility from our third-party providers. So on the right side, when you look at this green line, you will notice that there is a huge drop of volume in mid-October last year. We don't know what was going on, but suddenly all of our providers dropped the volume by a lot. And we realized that, so through research, we realized that usually the missing data comes from two parts. The total number of devices decreased. And also for each device, their behavior pattern changed. There is just less number of visits per device since October, mid-October. I don't think that matches the real world, right? Because nothing was going on October last year, not that I'm aware of. So what do? We try to come up with our own normalization algorithm to try to counter that effect, to try to compensate for that drop of pure volume. Some other alternatives people usually like to do are, for example, using the using the census data to try to match the raw volume to the census data volume. But there's a problem with that, which is that data is static, and also it's much slower and much lower resolution to reflect real-world changes. Where when we use our first-party panel as the base model for normalization, you end up with this orange line here, which, which matches the behavior, the trend of this green line, which we consider the ground truth, much better. I mean, of course, this methodology is not perfect because you can see towards the end of this line, there's like an upward trend, right? So that's what that's why we're continuing to improve our models. Overall, I think to conclude, nothing says this better than this famous quote from our computer science industry by Alan Kay. He said, "People who are really serious about software should make their own hardware." So here I just substituted software with data and hardware with apps, and I think the statement still stands. If you're really serious about your data quality, you should try to make your own apps to collect the data yourself. Thank you very much.
Thank you, Runxin. Probably we might have a few questions. I have a practice. Sorry. Is there a question?
Yeah.
Oh, yeah. Can we get the microphone there? It's on the opposite side. While it's traveling, I have a very practical question. I have 2 mobile phones with me. So how do you recognize me? As one person or 2 people?
That's a very interesting question.
And also, I mean, to make it even more difficult, I might carry one and go hand in hand with my wife with her phone. So how do you know it's me alone or it's a pair of us?
Yeah, interesting. So first of all, I would recognize you as someone who carries 2 phones.
How?
Right? Which is different from most people, right? First of all, if you have the Foursquare owned and operated apps installed on your 2 phones, if you use the same account, we will ask you to try to create a Foursquare account, right? If you use the same account on different phones, we know, right? It's connected that way. Even if you don't, I think, based on our algorithm, we should be able to tell similar visitation patterns from the movement patterns of your 2 devices. And we might not know that it's the same person, but we would be able to figure out that this belongs to someone with a very similar demographic. And that would be good enough for us.
Is 5G making this more better?
I don't know. I guess if you, like the famous quote there, if you really care about your software, you should make your own hardware, which means better hardware always, helps.
Okay, sorry.
Okay. So I must apologize if I missed some part of your presentation, but you were saying, we were talking about mapping the location to latitude and longitude,
yeah,
and trying to be as precise as you can, and with that example with 3 stores in the historic data, etc. But what about altitude? Shopping malls and the shops being one above the other, how do you solve that? Yeah,
so that's a very insightful question, because mall is always a very hard use case to solve for us. For example, when you are inside a huge mall, which contains a lot of small shops in it, right? First of all, your GPS signal is usually blocked by the building itself, so it has a lot of errors. Second of all, there is a hierarchy between the mall and the shops within, right? And the shops are relatively small and close to each other. So we try our best to come up with the snap-to-place algorithm based on different signals, different features, not just your GPS signal, right? For example, if you are someone who usually visit, sports shops very often, but never has visited say a women's shoe boutique, right? We know that probably you have much larger probability to visit this sporting shop inside the mall. So that's one way of doing it. We also try to use some other signals that are not GPS-based, for example, Wi-Fi signal from these different shops to help with the model. So yeah, it's a combination of a lot of different features.
Do we have any Here is the question, sorry. The microphone is coming. First row.
Thank you for your presentation. You mentioned that there is no benchmark for geolocation task. Do you know why? Why is that?
I think first of all, it's because the location data is much harder to acquire and label than, say, image data, right? Like, if you look at the NIPS dataset for character recognition or digit recognition, it has a long history of being a standard dataset for that task, right? We don't have the proper tools for labeling data, geolocation data. I mean, maybe Foursquare Studio can become a suitable tool for that, right? For labeling the geolocation data, because you can map the data on the map, which is easier for access. I think another reason is that geolocation data, like a lot of people haven't started realizing the value of geolocation data, right? And I'm sure, you know, the more we explore on this field, the more people will join this industry, and then maybe one day there will be a unified labeled data set for everybody to use. I'm hoping that Foursquare would be a pioneer leading that direction as well. Yeah.
Thank you. I don't see the... Oh, sorry. Those lights are killing me, so that's the problem.
Yeah. Thank you for your great presentation. I just wanted to ask you about third-party data and your first-party data from your app. What is the difference and what data you buy from the third parties? Is it the same data? And if it is, why you are acquiring this through the third party?
Thank you. That's a great question. So the main reason for purchasing third-party data is to supplement what is missing from the 1P data. So we try to buy something that is very different from our first-party data. The providers are actually they don't actually generate the data themselves. I think they are more like a data vendor who collects data from other different apps, right? Who they have contract to, and they do some kind of normalization or denoising themselves, and then they pack their data to us. The problem with that is because of this middleman, as these vendors are basically the middleman between the apps and us, right? So it's kind of like a black box. We don't know what they do. We don't know what's going on. Like that example you saw there, when a huge drop of volume happens, there's no explanation, right? So that's why we have to do our due diligence to validate their data on our side.
Okay, I think that exhausts
our
time. Runxin, thank you very much, and may I present you with the certificate for the speakers on the DSC.
Thank you.
Thank you.